Hello. So in this video, I'm going to share what I've learned about reactive programming, stream processing using this framework. Yeah, let's call it framework called Reactive X. Okay. Uh, so a little bit of background. How did I you know stumble upon this framework? Was a few years ago. I did a lot of programming using Node.js and lots of data processing, array of items from CSV files, for example. Um, and then I grew accustomed to this style of functional-ish programming, right? I don't actually know what's the difference between functional and functional-ish. They call it functional-ish. Well, in my eyes, it's functional programming because it's to me functional programming is like when you the building blocks are functions and you build your features by like plumbing those functions, right? So that's to me that's what functional programming is. Maybe I'm wrong, but anyway. So I'm accustomed to this using a library. I do lots of data transformation using Lodash, this library. So I'm familiar with functions like map, reduce, filter, and all these functions that you see here. But then I hit like a very very big CSV files, and of course I cannot load all of them into the memory. I need to wait to process those records, in a like in a streaming way, right? And so I look for the equivalent of this library, but for stream data, right? So that's how I came across this Reactive X. Reactive X it's used by these big companies. Yeah, you see Netflix here. They do a lot of streaming, I suppose, and um, and it has implementations in several languages. For example, this RxGS, that's for JavaScript. These are all the functions they have in our RxJS. They call it operators. So let's just start using this term operator, right? And now that I'm switching to Golang, I use this library, RxGo. RxGo here. Okay, so let's just get down to the code, and so I'll start by explaining the basics. The key concepts in this framework is called observable. So let's just see the documentation. What do they mean by observable? So the blah 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 push collection. So if you start reading more about it, then there are two types of observable, like a hot observable or and cold observable. So so this is it. Cold. There are times when you prefer the hot. Hot is like you don't have control over the you know the productions of data in the stream. You just listen to some external sources. That would be hot observable. But if you have total control of the emission of the items, probably you would want the cold observable, something like that. So in our case with the CSV, because my own code read the CSV and then start emitting line by line. So in that case, I use cold observable, right? Okay, so this is, so the key concept is observable. And to put it simply, it's the stream. So by this, we're creating a stream where each item in the stream is a number, like this one. So what's the difference between array and stream actually? Well, how do I explain that? Array is more like, probably all of them in memory already, I guess. While the stream is it just pops up from somewhere, maybe from socket, from asynchronous IO operation, things like that. So you don't, it can be open-ended, right? So that's how I see the stream. But in this case, you got a stream with a, known n. You got like only 5 items in the stream, but you create a stream here. Now, to consume item in the stream, you use these 3 callbacks. This one is for, like normal value, and this one is for in case of there's an error in processing the item, or processing the whole stream. And this one is when the end of the stream is reached. Okay. And this call is blocking. No, it's not blocking. It's actually return a channel. Well, it's disguised as this type, which is just a channel actually. A go channel. Yeah, so it returns a channel. So if you want to wait until the entire stream is processed, I mean until the end of the stream is reached, then you have to add this thing to the invocation of this function, right? That's just the way we do it in Go. So yeah, that's simple. We got stream and we got a consumer. Now, things get interesting when we start applying operation in the middle of it. Now we have like pipeline, right? So we apply what they call operators. So what operators do we have specifically here in the RxGo? So these are list of operators that we have. Let's start with a simple one called map. Where is it? Map. Okay, damn, I'm not good at searching this. There you go, map. Nice, you got this illustration here. Yeah, you apply the map operator. So for each item, these functions will be applied, and then it spits out whatever is the result from the operation, right? So this example, it multiplies the number by 10. Man. Okay, now an operator usually, I'm not sure if it always, but usually it returns another observable. See, map returns observable. So you can actually chain this call like this: observable dot map returner observable, and then you consume the the final observable, right? And this dot map each operator actually create a new instance of observable. So if you do it like this, you won't see you won't get what you expected. What we expect is you'll see consuming 10, consuming 30, consuming 50, right? But if you do it like this, you got 3, as if the map was not executed. The map wasn't executed actually because it's lazy. And beside, you never subscribe to this second observable. So this dot map returns another observable, like another stream. So so in this case you are supposed to consume observable 2 instead of observable 1. You run it, then you get the result that you expected. So that's how it works. So let's go back to a more clean way to do it, like this. Yeah, cool. Now let's apply, just for the show maybe, let's apply another operator so you can chain operators. Speaking of, I forgot to mention like the basic idea, the motivation maybe. Okay, doing ETL, doing data transformation, you can do it like the conventional quote unquote way. I've I've seen codes like that, and of course we can read that. Well, we can read through the code to see the intent of the code, but it takes more time compared to code that speaks in a limited set of vocabularies like these operators. So it's you can see it as like a vocabularies for data processing. For yeah, it's easier to communicate. Oh, we need to get this shape of data at the end, so we need to apply this and this operators throughout the stream of data. So it would be easier to talk like that. So it's in the same spirit as design patterns, right? In the object-oriented programming. So that's how I see it. The value of libraries like this. Okay, go back. Let's apply another operator. Group by dynamic. Where is it? Group by dynamic. Group by dynamic. Ding. So what does it do? We want to split this stream into two substream. Why? Because we want to group it by whether it's even numbers 2 and 4 or odd numbers, these numbers, right? So so 1, 2, 3, 1, 3, 5 will go to the stream for even numbers. 2 and 4 goes to another stream. So that we use group by dynamic for that. Group by dynamic. And you pass it these parameters. The first one is the grouping function. So for each item, you just have to map it to a key. So in this case, what I would do is if mod by 20 equals 0. I hit this. Why is it coming up? This strange character. Give me a second. There you go. Whoa! What is my keyboard? It's already Latin American. Fuck. This is the problem I have with the Latin American keyboard. It just have some strange keys. Damn. To get rid of this easily. Give me a second. There you go. I need to be careful with the button I press. Damn it. Damn. Again, I need to press the Alt GR. This is the I keep forgetting it. If Alt GR, there you go. Maybe I should just get a English keyboard for programming. If now, what is the second parameters? This is a bit complicated to explain now, so I'll just put number 3 here because I know, or we know, that each group will have maximum 3 items, right? Because otherwise, if I specify 1, you'll get blocked. We'll see that later as I explain this, near real case example. Blah blah blah. Okay, let's just run it. Let's see what we got. We got panic. What is this? Return non-bool item type. Oh, if item sorry, equals 0. Okay. Yep, exactly. Wrong here in this line. So the type assertion failed, of course, because now let's illustration time. Where's my pen? F9 to start drawing. Yeah. How to delete F10? Yeah. So we got this stream with items, simple items 1, 3, 5, 4, 2. Okay, this stream. And then we apply the group by dynamic operator. What comes out of this operator is another stream, of course, where each item in the stream is also a stream. So the first item is a stream that contains even number, no, odd numbers, in this case the first one, so it would be 1, 3, 5. The second item would be 2, 4. Okay, now we try to consume it here in this block. Consume it. We try to cast this as an integer. Of course, an error, right? So what we need to do is, first we cast it to the correct type, which is RxGo dot group observer. So this is a more specific type of observable. It has additional field called key, so we can print it here. Consuming, start consuming items for key stream, substream, substream. Okay, you see a little detail here. In the operators, like map or group by, what we get is an Wait a second. Oh no, it depends. Oh, not the same. So for the map, you get the value right away. The value. So we'll just use value here to make it clear. But for some operators, you don't get value, you get item. What is item? Item is just a wrapper for the value and the error. So if there's an error, you can, inspect it in this field. Why do they do it this way? Why don't they pass item here in the map function? Because and why do they? Okay, fine, I understand that you don't. If there's an error in the previous operator, it wouldn't go to this map. But what about the group dynamic? Why do they decide to use item here instead of just the value? I don't know. Yeah, so if the callback for each operator can be different, so you just need to see the documentation or go into the source. No, it doesn't even. Let's see. No, it doesn't even say that. So you go to the documentation. That's the easiest way. Just see the example. Anyway, here you don't get at the end when you consume that you get the value. In this case, the value is on stream, right? You cast it to group observable, and then you can just type it here. Okay, run. Okay, you see? Sorry, substream key R, boom. But we haven't yet consumed the items in each substream, right? So to consume that, we can use for each. We can use this way, like just wait. Yeah, we want to make it blocking. So that's substream. The same for each. And the same like this. Specify three callbacks. Cool. And see, so the first item from the group by is this F9. It's this one. Yeah. The substream, and then here in the for each, you consume one. Well, no, in this case it's 10, 30, 50, and then the second substream. You go back here again, and it's 20, 40 or 20, right? So okay. I hope it's clear. Control F9. Now you may be wondering, hey, I don't want to so here this is, let's just change the ordering of the data. Let's see, 2, 3. So you get odd event. So let's see how it works. 1, 2, 3, 4, 5. Run. Yeah, so yeah, it works correctly as well. It groups them correctly. Now you might be wondering, hey, at this for each, I don't want to, read observable. I just want to get the items. How do you do that? Now there's another operator called Flatmap. Okay. it's very useful. I'm sure you'll find the needs for that quite often as you work with streams. Okay, in this case, 1, 2 here. Flat map, flat map, flat map. What do I get here? Flat map, return observable. Okay. You see, let's move it here. Here, yeah, we know that for each return dispose. Let's say we apply our map here. Apply our map. The function. Okay. Fuck. Map. Why? Oh, because of this. Yeah. Turn map value. Give me a second. Give me a second. The item here, the item is not a simple value. As we know, it's a stream. Okay. Substream, yeah, right. Then the substream. So we got the first item would be a stream with 135, and then we apply operator here. We divide it again by 10. And then here we simply for item I, it's E. Non-Java type. What is this flat map? What's going on here? Invalid type assertion. Let me do a simple thing. Item, it's after, sorry, of course. You see, item, to get the value is we have to press .v. Right, now it should work. Okay. You might be wondering what just happened here. Okay, maybe illustration will help now. How to delete this? F9, clear screen, F9. Get here. First, again, we start with the original. Fuck. F10, it's not Control Z, F10. The 1, 2, 3, 5, 4, 5. And then you got the group by dynamic, you got one, sorry, F10, 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 F10. It only has like limited undo operation. Clear screen. Let's start again. F9. The original stream. 1, 2, 3, 4, 5. Okay. And then you apply the map. This one. You got 10, 20, 30, 40, 50. Yeah. You got the, and then you apply the group by dynamic here, the second operator. Group by dynamic. So the output stream will contain streams 1, 3, 5, and the other one is 2, 4. Now we get to the interesting part, the flat map. The flat map here, we inside the function, how do we process these items? These items we, no, in this case it's 10, 30, 50, 20, 40. We just apply this division by 10, so actually we got still a stream. Now go back to the value 1, 3, 5, 4, 5. Well, this is what happened if we don't apply flat map. If we only apply the simple map. Now, if we apply flat map, what happened is this stream will blur. That's how I visualize that. And I cannot. It doesn't have eraser, so sorry, I have to do it like this. So instead of having stream as items, we got the value directly out of those streams. So it's just as if this flat map just sucked them out of their shell and put it in this river. Right? So we got 1, 3, 5, 2, 4. That's what we consume here at the end of the stream. So that's how it works. I hope it's clear. Sorry for the drawing, it's just so ugly. Clear screen. Okay, so I hope at this point you already get the gist of stream processing using RxGo or ReactiveX for that matter. Now let's go to the a little bit more real example. What we have here. Just run it. Boom. So we have this file to process, the CSV. This is the ID of the product. And what we want is, so let me just draw it again. So let's start with the objective, right? So we got how many? 8 items here for each individual product for each store. So there's the same product but destined for a different store, like this one. They are the same product but for a different store, right? So we want to process these 8 items. This is sorry, F10, 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 F10. Clear screen. How to clear screen? Control F now. Control F9. Yeah. What? No. Give me a second. I don't remember. Clear screen. Shift F9. Shift F9. Okay. Shift F9. Oh, got it. So we got 8 item here. 5, 6, 7, 8. One is for store 1, for store 1, for store 2, for store 1, for store 2, for store 3, for store 2, for store 3. And this the DSKU is 1, 2, 1, 3, 3, 3, 4, 4. So this is the on this stream, and through some magics we want to have like let's say non-aggregate. So we want to not have an object. Let's call it. I don't remember how I call it in the code. I call it like product availability. That's how I call it. For product availability for store 1, and it will have inside of it item 1, item 2, item 3. Yeah, right. And then another object, product availability for store 2. We'll have item 1, we'll have item 3, and we'll have item 4. And the last one is product availability for store 3. We will have item 3 and item 4. So that's what we want, right? The final result. So, so let's resolve this mystery cloud, right? Shift F9. F9. Thomas! Jeez, come on. Enter, yeah. Let's just look at the code. Where is it? There you go. What do I do here? Read file configuration, blah. It was just the mapping thing. So I'm mapping. Okay, file configuration for this partner. This partner will map. How do I start explaining this? So let's start with the structure. For product, we have this structure. SKU, product name, store, right? Product availability that I just mentioned. You got the store name and list of product stock, if individual product with the information about the quantity. So this row is what we read from the file. But what is the role of file configuration? Like there's a struct called file configuration with a column mapping, because each partner or each brand will have different way to in the header. Maybe some of them will use like in Spanish nombre producto, something like that, but we need to map it to the structure that we have defined here. So that's why we came up with this file configuration. So okay, the first thing we need to do is read the file configuration for that partner from the database, and then we create a stream out of this file, out of this file. So what are we doing here? Okay, this is the way to create a code observable that I mentioned previously. Basically, you need to pass in array of what they call producer. Producer is the object that is in charge of emitting items. So yeah, emitting items into the stream. So we're creating this producer. What does this producer do? Well, it just first opens the file, open a CSV reader, decoder, and then do some basic checking. If there are missing columns, then we'll just throw an error, just push an error into the channel. Otherwise, it will start processing line by line. And for each line, it will emit this item, an item of type row. Okay. Yeah. So we know from the previous drawing, each item in the left side in the original stream or the input stream is of type row, which is this one. Okay, cool. Now we got that input stream. Where was that? Okay, so this records produce stream of rows. Cool. Now, why do I apply this operator called buffer with time or count? Initially, I don't use this. Initially, I just went straight ahead to this point. So let's say the initial code was like this. But it didn't work. Why? Because the group dynamic, you need to specify a parameter called the size of the buffer channel. Buffer channel is a concept from Go language. How do I explain this here? Actually, I have another video that explains the problem and explains why we need to use buffer with count or timeout. Because well, in this example, we know, okay, if for each store there would be maximum like 3 items, so we can just put 3 here, right? Well, but of course we don't want to put that assumption in the code. Besides we want to work with a really big file, so yeah, we can't use that. We don't know ahead of time what number we should put here, but it needs to be a fixed number. Another alternative would be let's just specify a really big number like that, so we wouldn't have this the blocking issues because of the buffer channel is full. But that's not good either, because you will consume a lot of memory creating this big buffer channel in advance when you might not need it, right? So we need to resolve this number like dynamically. So how do we do that? Yeah, with buffer count. So what we're doing here, basically, let's go back to the drawing. We got 1, 2, 3, 4, 5, 6, 7, 9, right? 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 6, 7, 8. With the buffer with time or count, and I specify here the time is, the count is, yeah, there's a second parameter here. Buffer size. 4, it's 4 here. And time is 3 seconds, so let's assume with the count. So it will be grouped this way. What comes out is a stream that contains 2 items. These items is not array. Sorry, it's not stream. It's array. Right. So it's an array, and so just to make it clear that it's an array, I'll just apply this lines like compartment. Now we got 1, 2, 3, 4. We got 5, 6, 7, 8. Okay. Now for each array, this is it. The rows. For each array, we create a stream out of it. So so there's a let's start with the mapping right here. So this first array will be mapped to an observable. Now it's a stream, no longer an array. And have 1, 2, 3, 4, and this is the second substream. 5, 6, 7, 8. Now for each stream, yeah, we're just doing like the way I explained before with the group dynamic. So what comes out of here is, in this case, would be item the product availability for store 1 that contains how is the data? That contains item 1, and then product availability for store 2. Well, yeah, we're just going to consider up to this point. That contains item 1 as well. 1 contains item 2, and also product availability for store 3. That contains item sorry, wrong. F10 1 1 2 1 1 2 1 item 3. Okay, that's what we got. But the stream, still a stream. It's a stream. Group by, using the group by dynamic. Now is this one as well. A stream that contains 2 items. Now we are going to consider this for less 4. Product availability for store 2 with item 3. Then product availability for store 3, item 3. Product availability for store 2, item 4. Product availability for store 3, item 4. So this is what we got. Now, thanks for the flattening, flat map, this disappears. So it just become like a single stream of these 4 big circles, right? That's what we got there. Add product stock, product just. Yep. So that's what we got. So finally at the end of it, yeah. So we got this F9 again F9. This observable correspond to this one, the final one that we have here. So we will have 4 items. So for each product availability, we'll send it off to, external system, maybe through messaging or something like that. So first we send this big ball for store 1 containing item 2, item 1, item 2, and item 3, and then we send the second big ball for store 2 containing only item 1, and then another big ball also for store 2 with this item 2 and 4, and so on. So that's hey, I didn't explain why I do the buffer with time and count, right? Yeah, the reason is because with the buffer size, we know that the buffer size is 4, so we know that the maximum number of item in the group is 4, right? So we can specify the same number for in the call for group by dynamic, because you remember the group by dynamic, apart from specifying the grouping function, you need to specify the size of the buffer channel. So yeah, this is just a trick too. So you need to split the original stream to a known size, which is in this case the buffer size. So you that way you avoid the blocking. Of course, you might ask, hey, but I want to store, I want to send, all the items for store one, in this case for store two, in one shipment. Well, you're out of luck here. You need to rethink your process. I mean, here we are splitting items for store two in two different shipments. First shipment with only one item, and then the second shipment only for with two items here. Yeah, but that's sometimes you just have to rethink the way you process your data at the end of the stream on because of these reasons, right? Um, well, yeah, I always find it a bit difficult to explain uh, stream processing or functional programming, for this matter. But I hope I did pretty well here in explaining this whole thing. And I believe that these ways of programming, especially for data processing, is still better than doing it the imperative way. For the first reason that I mentioned, we have like this set of vocabularies. It helps in the communication. It makes your code also more standard, shorter. And the second one is, well, we work with stream here. We no longer have to load the entire, in this case, the entire CSV files into memory before we can process them. Yeah, that's the beauty of this reactive X. Well, what else? That's all. That's all. I share this where here. Oh, this is another project that I did. Just showing off, showing off RxG stream programming. I made like a mathematical expression evaluator, uh, and then I did it the streaming way. Uh, but for this demo video, I haven't. This one, you can check out the code here in this repository. All right, that's all. See ya later. Bye. Yup. Boom.